The last section in this unit is section 4.7. The title is Arithmetic Sequences. Arithmetic sequences. And a sequence is just a set of numbers in a specific order. A set of numbers in a specific order. And terms are the numbers in a sequence. So if it has 10 terms, that means it has 10 numbers in the sequence. Okay? An arithmetic sequence specifically, because we'll talk about an arithmetic sequence today, and at the end of the year we'll talk about geometric sequences. But an arithmetic sequence is a sequence in which there is a common difference between all the terms. Okay, what's the common difference? The common difference is easy to find if you we're figuring out how far each sequence is from each other. For example, let's say we have this 1, 3, 5, 7. Okay? To find the common difference, you can take the second term and subtract the first term. So 3 minus 1 is 2. Take the third term and subtract the second term. 5 minus 3 is 2. Take the next term and subtract the previous term, and 7 minus 5 is 2. So you can see the common difference here is 2. So you can find the common difference by doing the second term minus the first term. This is how we talk about the second term. It'd be a sub 2, that's the second term. A sub 1 represents the first term. Or you could do the fourth term minus the third term. Or you could do the third term minus the second term. We can find it by subtracting any previous term from that term. So let's talk about identifying arithmetic sequences. Determine whether each is arithmetic and justify your answer. Now, in order for it to be arithmetic, you have to be able to find this common difference. It has to be the same between all the terms, each of the terms. So determine whether each term is arithmetic, justify your answer. Well, 5 minus 1 is 4. 13 minus 5 is 8. 19 minus 13 is 6. So these differences are not common. They're not all exactly the same. So this is not an arithmetic sequence. Not arithmetic. Okay? Let's try this one. 1/4 minus a half. 1/4 minus a half is 1/4. 0 minus 1/4. I'm sorry, this is negative 1/4. 1/4 minus half would be negative 1/4. 0 minus 1/4 would be negative 1/4. And negative 1/4 minus 0 would be negative 1/4. So the difference between each of these, when we're going down, you subtract 1/4, subtract 1, well, we're technically adding 1/4. So when we go this way, subtract a fourth, subtract a fourth, subtract a fourth. And since it's the same every time, it is, yes it is, arithmetic. So the first thing you want to be able to do is identify if it is an arithmetic sequence or not. Once you know that it's an arithmetic sequence, then you can extend the sequence by finding more terms in the sequence. So this one says extend a sequence, find the next 3 terms of the sequence. Negative 8, negative 11, negative 14, negative 17. So you just need to figure out what the common difference is first, and then we can keep on going. So negative 11 minus 8. You have to be careful with this one because they're negatives. So let's write this down. Negative 11 minus a negative 8. You're really adding these. So we get negative 3 between these. Okay? Or you can also ask yourself this. What am I doing to this one to get to here? We're subtracting 3. To get from here to here, we subtract 3. To get from here to here, we subtract 3. So there's two ways you can think about it. You can actually do a subtraction from this one to this one, or you can ask yourself, what are you doing to this one to get to this one? So we do have a common difference of negative 3, and if we want the next 3 terms in the sequence, negative 17 minus 3 would be negative 20. Negative 20 minus 3 would be negative 23. And negative 23 minus 3 would be negative 26. So make sure you pay attention to how many terms it wants you to add on. Find the common difference first, and then just continue on with the same common difference. Pretty easy. Okay? Now, besides extending a sequence, you can also, once you know that it's an arithmetic sequence, you can find specific terms in the sequence. So this is the formula for the nth term, and nth means you can put in any one. So if I wanted to find the 8th term, wherever there's an n, you put an 8 in its place. If I wanted to find the 21st term, instead of having to do what we did here in this previous example and going 21 times out, you can use the formula instead. If you wanted to find the 50th term, you would not want to have to do it this way till you get to the 50th term. So that's where this formula comes in handy. So the nth term, which we call a sub n. So if it's the 8th term, we would say a sub 8. Okay? The nth term, a sub n, of an arithmetic sequence, with a first term, which is a sub 1. And we kind of talked about that up at the beginning. And a common difference, d. So the first term is a sub 1. The common difference is called d. And if we want to find the nth term, we're finding a sub n. A sub n. So here's the formula. A sub n equals a sub 1 plus n minus 1 times d. So if we want to find, for example, the 8th term, we would plug in 8 for n. A sub 8 equals a sub 1 plus 8 minus 1, which is 7 times d. But we still can't figure out all of this because we actually need to know what the first term in the sequence is and the common difference in the sequence is. So whatever term you're trying to find, you plug that in for n. And then you also have to plug in the first term and the common difference. All right? So let's try a couple examples on the back using this formula. Find a specific term. Find the 14th term in the arithmetic sequence. You do not want to have to count this out. So in order to do the formula, let's go ahead and write the formula. A sub n equals a sub 1 plus n minus 1 times d. So we know n is the 14th. We're looking for the 14th term. So n is 14. So a sub 14 equals a sub 1. So what is the first term in this sequence? That's easy. It's the first one. 9 plus n minus 1. N is 14. So that's 13, and the common difference is the other thing we need to fill in. So what are we doing to 9 to get to 17? We are adding 8. 17 to 25, add 8. 25 to 33, add 8. So the common difference is a positive 8. Now some people like to write out before they do anything that we know n is going to be 14, a sub 1 is 9, and the common difference is 8. If you want to write those things out first and then plug it all into your formula, you can do that too. So a sub 14 equals 9 plus 13 times 8. And so we do 13 times 8 and add 9 to it, and we end up getting 113. So the 14th term in this arithmetic sequence will be 113. And that takes less time than having to do it over and over again until you get to the 14th term. All right. What about B? Would you really want to have to do this 73 times to get to the 77th term? Absolutely not. So if we want to find the 77th term in this arithmetic sequence, you need to know n is 77. You need to figure out what the first term is and what the common difference is. So what will the first term be? Again, that's pretty easy, -3. And the common difference, what are we doing to -3 to get to -7? What are we doing to -7 to get to -11? We are subtracting 4 each time. So the common difference is subtracting 4. So we write out our formula, a sub n equals a sub 1 plus n minus 1 times d. And a sub n would be a sub 77. The first term is -3. N minus 1 would be 76. And the common difference is -4. So 76 times -4. Now when you put in -4 here, it's really important actually that you put that in parentheses so it doesn't look like you're subtracting 4. Some people, some books, will write the formula with the D in the front, and I actually think that works out a little bit better, D here, and then you get the -4 in the front and the 76 behind, and there's no confusion as to whether you're adding these, subtracting them, or multiplying them, because you'll know that you're multiplying them every time. So we do 76 times -4, and then we add -3. And you should get -307. Okay? You do have to memorize this formula. So let's go back and amend this formula. It might be safer and easier for us to, instead of the D on the back side, we put the D on the front side. Let's put it there so it makes a little bit more sense and there's less confusion when we're plugging in numbers. Example 4, writing an equation for a sequence. So this takes us even a step further, a kind of an application step here. We know that we're using this sequence, 12, 23, 34, 45. We want to write an equation for the nth term. And then we're going to find the 10th term and graph the first 5 terms. So what do we know? We don't know what the nth is. So a sub n, we're going to use our formula, a sub n equals a sub 1 plus n minus 1 times d. So since we're going for a generic nth term, the n's will stay this time. We can still find the first term, which is 12. The n minus 1 will have to stay, and we can still find the common difference. So what do we do from 12 to 23, from 23 to 34? Okay, we are adding 11 each time. So the common difference, which we're going to put up here, is 11. Okay, so we want to simplify this equation. A sub n equals 12 plus 11n minus 11. A sub n equals, combine like terms, 11n plus 1. 12 minus 11 is 1. And here's our equation. Okay? So this is our generic equation. It works for every single term. Once you have your generic equation, then you're going to go specific. It says find the 10th term. So now we know we're looking for a sub 10. So it's 11 times n, which is 10, plus 1. So we get a sub 10 equals 110 plus 1, which gives us 111. So this is the second question. First one was to write an equation. The second one was to find a specific term. And then it says graph the first 5 terms. So if we were to make a table here, and we want to graph the first 5 terms, where n is 1, 2, 3, 4, 5. Okay. If we plug it into this formula, a sub n is 11n plus 1. 11 times 1 is 11 plus 1 gives us 12. We've got, we already actually know the first 4 terms because they're all right here. So we can use those still. But the second one, 11 times 2 is 22, plus 1 is 23, which does match our original problem. 11 times 3 is 33, plus 1 is 34. 11 times 4 is 44, plus 1 is 45. And 11 times 5 is 55, plus 1 more is 56. Problem here, we're going to run out of space on our graph, but if we graph 1, 12, we can actually, let's make this our axis here. And we'll go with this axis here. We'll get a few in here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We won't get many in. 2 and 23 are going to head off. So we can call these by 2. Let's see if we can do that. 1, and then this is 2. 2, 4, 6, 8, 10, 12. Okay. 2 makes this 12, 14, 16, 18, 20, 22, 24, which makes that 23. Let's see if we can fit one more. 1, 2, 3. This is 23. 24, 26, 28, 30, 32, 33. So that's giving us the beginning of our equation here. So 3 things. Write an equation for the nth term by plugging in just your first term and your common difference. Leave the n alone. Leave it in there. Simplify it. Once you want to find the 10th term, you just plug the 10 in each time you see an n. And then if you want to make a table of values to find your first 5 terms and graph them, then you can do that.